All right. So we're going to start and let's go for it. Guys and girls, you can make little notes as we go along. Just date it. Make sure you got the 9th of July and you've got, if you want me to put the heading up again, lesson 16, revision, volume and density, just so that you know exactly what was being done on this particular day. Okay. The volume, the first thing we're going to look at is something called a regularly shaped object. This is things like we've been dealing with cubes and rectangles. There are other shapes, we don't have to know them. We're working with regularly shaped objects. And the best example over here is the cube. Okay, or this isn't a cube, it's a rectangle. All right, and so in order to actually calculate this, we need a formula. And the formula for this one is volume is equal to length times width times height. Now, sometimes they change it slightly and they say length times breadth times height. Means the same thing. Okay. We summarize it to L times B times H. B is width. Okay, we talk about breadth instead of width. So volume is equal to LBH, length times breadth times height. And then all you do is you take your values and you insert it. So it's going to be 10 times 5 times 9. And I'm going to end up with an answer in this particular case of 450 cubic centimeters. Okay, first of all, why is it cubic? Why is there cubic centimeters there? Because we're working with volume. Now, please correct me if I'm wrong. It says 10 centimeters times 5 centimeters times 9 centimeters. So there's 3 of them. 1, 2, 3. Okay, so that's why it's cm to the power of 3. There's 3 measurements. Do you have to write these centimeter here, and centimeter here? No. Doesn't have to be written in. Gotcha. Then it's not volume. Okay. If there's 19 of them, that'll be 10 to the power of 19, which doesn't exist. Okay. All right. All right. For volume, we only need length, breadth, and height. Any questions? That was a good one. Any other questions? Not at this stage. Okay, so when we've got a regularly shaped object, we just use a formula, we can get an answer. Now, these you need to quickly learn out of your head. No, I'm joking. I'm just joking. Ladies and gentlemen, what I thought I would do is, I thought I'd show you a huge amount of different shapes and their formulas. Now, every single one of these guys has got a volume formula, and it's even got a surface area formula. We don't have to worry about the surface area. So check out these different shapes. Every single one of them has got a formula to actually work out its volume. All right. We don't have to know that. It's just for interest's sake. All right. So for those who aren't interested, you can go back to sleep. No problem. Okay, ladies and gentlemen, now we're going to look at the volume of an irregularly shaped object. How do I determine the volume of a shape that is not a circle or a sphere or a triangle or a rectangle? How do I work out its volume? If somebody could just go to that window over there, there's a rock in the window. Please hold it up. Guys and girls, how am I going to find the volume of that rock? I can't measure it. It's not a square. It's not a rectangle. Thank you so much. It's not a prism. How am I going to determine its volume? Yes, sir. Yeah, we put it in a measuring cylinder. Do we put water in it or do we do it empty? Yeah, we put water in it. How many of you have climbed in the bath and the water level rises? Every single one of you. If not, you're invisible. There's a problem. Okay. Ladies and gentlemen, it's called the Archimedes principle. As soon as you climb in the bath water, it pushes the level up because it's displacing your volume. So what happens is it's displacing the volume. Now, please jot this down. 1 cubic centimeter is equal to 1 milliliter. Now, the reason I've included the second one over here is because the Americans, some of the worksheets I use are American, and they've got little m, big L. It means the same as this guy. You know the Americans, they like to be different. Mainly because they don't know what's going on anyway, so they just carry on. Okay? So, ladies and gentlemen, please, 1 cubic centimeter is the same as 1 milliliter. Now, why am I saying this? Because cubic centimeters is usually a regularly shaped object. When you measure that rock, you're going to get the answer in milliliters, because the measuring cylinder measures milliliters. Then you convert it straight to cubic centimeters. Let's have a look. I've got an example here. So the first one, the level over here is 60 milliliters. Okay, the measurement here is milliliters. You pop the stone in and the level goes all the way up to 80. This is 80 milliliters. So what's the volume of the stone? Yes, 20 what? Milliliters. How did you get that? Yeah, that's it. I took the reading over here, which was 80, and I subtracted the 60, and I got 20. So the answer is 20 milliliters, but the stone, you then have to change to cubic centimeters. So it will be 20 cubic centimeters. Everybody okay on that? Right, and then there's a second example. Yeah, again, you'll notice this measuring cylinder does not have units on it. I chose this one because the person who drew this is not a scientist. If you're busy giving these questions, ladies and gentlemen, you have to say to the people, guys, this is measuring in cubic centimeters, which you can, or it's measuring in milliliters. Okay, you get the idea. So if you look at this drawing, ladies and gentlemen, what is the volume of that irregularly shaped object? Anybody? Yes, ma'am. So, 50 what? 50 cubic centimeters or 50 milliliters. Well done. Okay, so it's 300 over here. 300 minus 250 gives you 50. So it's 50 milliliters or 50 cubic centimeters. Everybody clear on that? All right. If we move on to density, can anybody please give me a formula, not a formula, a definition? What is density? Anybody? Come on, invent one. Yes, what did you get? That's basically a description, how compact an object is. Good, but I need a definition. You're not wrong, but you haven't answered the question fully. You understand why I'm saying so? Okay, guys and girls, the definition is the amount of matter per unit volume. The amount of matter per unit volume. That's the definition. What you gave us just now was a description. It's just as good, but it's not a definition. Well done there. I like it when you people try. That's the way I'm saying. And then what I've done is I've included the units of measurement. Here was the one we usually work with, grams per cubic centimeter, but you also get very large units, kilograms per cubic meter. Okay, this is the one we usually work with. Now, ladies and gentlemen, can I ask you this question? Let me see if I can draw on this. Let's get a highlighter. Can I replace this? Where's my highlighter? Come on, I need the color, please. Can I replace, it's not allowing me to write. Let's try this again. Give me a pen, please. Can I replace this with milliliters? Can I change this cubic centimeters to milliliters? So my answer will be grams per milliliter. Yes. That's why I gave you that thing at the beginning. All right, now please be careful. Some of the worksheets and stuff you're going to see when you're going to do the work uses this unit. Now you know, Mr. Maynard showed us, this is just because they were too lazy, probably Americans or whatever, and they didn't put cubic centimeters, they put milliliters, which is fine, no problem. Everybody okay with that? Right, moving on. Density is given by the formula mass over volume. You don't have to know this out of your head. It will be given to you. This will be given to you. The quickest and easiest thing to do is shove it into a triangle. Because sometimes, and you're going to see this when you're going to go and do your exercises, your revision exercises, sometimes they give you the density and they want the mass. So you need to be able to change the formula. Now, ladies and gentlemen, if you look at that triangle, the two at the bottom there, density and volume. What is the mathematical relationship between the two? Add, subtract, multiply, or divide?
Multiply.
When the two, well done. When the two of them are next to each other, it's multiply. What is the mathematical relationship between mass and volume? Divide. What's the mathematical relationship between mass and density? Divide. Okay, so now what do? If I need to work out volume, I write down volume is equal to, and then I go to the triangle and I see, oh wait, these two are on top of each other, so it's mass divided by density. Everybody okay with that? Now please, ladies and gentlemen, the formula will be given to you. My suggestion, shove it into a triangle, and then you can do anything with it. Okay. Any questions on this? No questions at this stage? All right. So now, yeah, we got a little picture to indicate a bit of density. Which one of these is the most dense, A, B, or C? A, because it's got a more regular shape. Okay, you can squeeze more in. This one is not going to be as dense. This one is a joke. Okay, it's less dense. Now, guys and girls, let's say for argument's sake, I can get hold of 20 kilograms of polystyrene. It's probably going to be almost the size of this classroom. And I go and I get 50 grams of lead, which will fit in my hand. It will probably be the size of my eraser. If I go to the swimming pool, which one of those is going to float? Which one's going to sink? Yeah, but the polystyrene is 25 kilograms. It's not dense. The tiny little piece over here of lead or whatever, it might not be have the same mass, but it's denser. Everybody okay with that? All right. So here's a picture of 3 cylinders, and they are filled with water. There's, well, half filled with water. Okay. Now, an interesting thing I need you to quickly jot down. The density of water is 1 gram per cubic centimeter. The density of water is 1 gram per cubic centimeter. Nice exam question. Now, the density of water will be given to you. You don't have to know that out of your head. Right. Interesting question over here. Let's call this beaker 1. We call this guy beaker 2. And we call this guy beaker 3. All right. Which beaker has an object that is denser than water? Number 3. Obviously, it sinks. Which one of those, 1, 2, or 3, has the object has a density almost the same as water? It can only be 1 or 2. if the density is almost the same as water, has to be 2. Okay. Number 1, can you see most of it is out of the water? So that means the density is less than water. Get the idea? All right. So now we use that principle. Here are 2 beakers. They've both got mercury inside them. Unfortunately, it's not a good thing to play with mercury. The vapor is poisonous and the mercury is absorbed straight through your skin into the blood. And it can give you mercury poisoning. Now, ladies and gentlemen, if you stick your finger into the mercury, it's not going to kill you. If you work with the stuff for a number of years, yes, then it will. Because then it accumulates in the blood. Okay, everybody all right with that? So now, please tell me something about the density of this guy over here on the left and the density of the coin on the right-hand side. Come on, tell me something about their densities. What's that? Which one? Both of them. Would this one be almost very similar to mercury? Very similar. Okay, because it's floating almost out. It's almost sort of like the picture we saw in the beginning. It's almost like this guy. All right. But this guy over here is definitely number 1, floating out. All right. So what does this tell us about the density of the objects? Mercury is very, very dense. Now, believe it or not, there's a chemical that's denser than mercury. Okay, I want you to go and find out what it is, just for interest's sake. Okay, now we get to some shooters. Now, I know you guys are thinking, yes, because you guys enjoy your shooters, eh? Not so. Yeah, that's why lockdown was so much fun, eh? Anyway, now, ladies and gentlemen, what they've done is they've taken a container and they've put in liquids of different densities. Okay. What they've also done is shove in a few objects. Here's a ping pong ball. This one over here is a ping pong ball. Okay. Here's a soda cap. I can't quite see where it is. It says beads over here. I presume that's them over there. I'm really not sure. Here's a cherry tomato. There it is. It says dye. I have no idea. Popcorn kernels. I think that's one of them. And then obviously that's the bolt over there. All right. Which one of these liquids is the most dense? Which one of these liquids is the most dense? The honey. Okay. Which one of these objects is the least dense? The ping pong ball right at the top. Which liquid is the least dense? The lamp oil. You get the idea? Now, please tell me, why are these pop kernels over here floating on top of the corn syrup, but they're at the bottom of the maple syrup? You look carefully, it's floating over here. Why is it on top of the corn syrup and why is it underneath the maple syrup? Somebody was answering. Yes, ma'am. It's denser than the maple syrup. That's it. Now, ladies and gentlemen, can you see you have enough knowledge to answer this question? We didn't do this in class. We didn't make that layer. We didn't do it, but you can answer the questions based on your knowledge. You get the idea? That's what I expect you to be able to do. All right. Any questions on this? Everybody all right with that? All right. Ice and water. I put this in as an extra. It's just for fun. Okay. Ice has a density of 0.92, just for interest's sake. You don't have to know this off by heart, just a bit of interesting stuff. Can you see that it's 0.92? It's almost 1. So the density of ice is less than water. All right. And that's why ice floats on top of water. But it floats in it, not on top of it completely. All right. Now, you don't have to know this, but ladies and gentlemen, if you look at the water molecules here on the left-hand side, there's not really a pattern. However, when water freezes, it forms a definite pattern. And water expands when it freezes. That's why it becomes less dense. That's why the ice floats on top of your brandy and coke at night when you get home. Okay, yeah. All right. So it's just an interesting statistic, not necessary. Yeah, we've got an iceberg. Now, please remember, there's an expression that says, oh, that's just the tip of the iceberg. When somebody says that, then you know there's much more of it underneath. Okay. When you see an iceberg, that's the bit that's managing to stick out the water. Most of it is underwater. Somebody asked me a question yesterday, is that ice very hard? So guess what I said to them? Guess what happened to the Titanic? It hit an iceberg. And that iceberg cut the whole side open. Metal, cut the metal open, just smashed it. So yes, it's very hard. Okay, and that's basically it. That's all we need to know. So what, any questions from the guys at home? Everybody okay with that? No questions yet? All right, I want to share one more screen with you. Guys and girls, if you go to your device in Google Classroom, you've got all of these worksheets. Here is the PowerPoint you've just seen in the bottom right over here. Everything else is worksheets. Okay, now I do not expect you to do everything. Some of these have got like 30 questions on them. You only do a few. If you're not getting it right, do some more. Now, one of these has got the answers on them. I suggest you start with that worksheet. Let's see if it's, I think it's this one. Let's have a quick look. No, not that one. Let's see, it's this one. Yeah, this one's got the answers. So I think this one goes with this one. It goes with this particular one. Des Mancy, this one. Here's the questions. Here's the questions. And here's the answers. There's a couple of them. I think this one's also got, yeah, this is a nice one. These are brilliant. Every single one of these worksheets is going to challenge you. Okay. And it's to get lots and lots of practice on mass, density, and volume. Now, you'll notice there aren't many questions on mass. I'm not going to be looking at weight, in other words, to do with the moon and gravity and that. We're not touching that at all. Okay, we do it again in grade 9. So please, ladies and gentlemen, there is also a quiz. I'm just scrolled up. This quiz, it says not for marks. So you're welcome to do it, but it won't count towards any marks. And it's also based on volume and density as well. All right. So basically what I'm saying to you is you've got a huge amount of work to practice because your mom and them are going to phone the school and they're going to say, Mr. Maynard, have you provided extra revision work for my child? And I'm going to say to him, yes. Ask your child to show you. And then you'll be able to say, look here, Ma, here's all the work.